the call. As I said, we are recording, so we will be sharing it afterwards. Myself, I'm Laura van Niekerk. I work for Gearbox, and today we are starting a series where we focus on CFD. The majority of it's going to be a training session, and today we are focusing on more SpaceClaim and meshing side of it. So as you all received in your email, this is event 1 of 3 events that will be taking place this Friday, next Friday, and the following. As I said, we are recording it. We will be sharing it with everybody. And please ask any questions in between. We do have Keith from Qfunsoft taking the session for us today. It looks as if there's already a question. Barrington.
Hi.
Everybody hear me?
Yes, I can hear you.
Loud and clear.
Loud and clear. Donington, unfortunately, yes. Maybe try and see if you can sort out your sound. Alternatively, we will be sharing the recording.
All right.
Okay. So yeah, with that, so as I said, welcome everybody. It's the start, the first event of 3 that will be following, and today's session is the first one, which will be presented to us by Keith. So Keith, you can take over and you can start the session for us. Thanks a lot.
Okay, so there we go. I was on mute. Okay, so we always have that. Okay, so welcome everyone. My name is Keith and I work for Qfunsoft. I specialize in CFD, so I spend most of my time supporting or doing consulting with CFD. So today is a bit more of the pre-processing. So we're going to start off with in SpaceClaim, which is one of Ansys's 3D CAD suits. So we'll look at how we manipulate cleanup geometry so that we can get ready for a CFD. So I'll show you the ins and outs of what we require to have a good CFD model. Right, so I have open here SpaceClaim and I will open my file. So I'm going to click open, and I'm going to select tank initial. Okay, so let's allow that to open. I'm going to just show everything and zoom in. So we have a little bit of a tank here, and there's quite a lot of detail in it, unnecessary detail that we don't require. Then let me show you just basically an inside. So I'm going to do a cross section by selecting the arrow and then hitting X on my keyboard. Right, so we have this tank, and in the tank we have an impeller and we have a heating coil. So we have multiple inlets, but the inlets we are interested in on these 2 smaller ones. We have 2 separate fluids coming in, and we require to heat it and mix it sufficiently, and then it exits out the bottom over here. So we need to clean this up and get it ready for the CFD and for meshing. So I'll get started. So before I do that, I'm just going to quickly show you an overview of what SpaceClaim is. So SpaceClaim, we have on the right-hand side, top here, we have various toolbars, and in these toolbars, there's various tools that we can use. The main one is the sketching toolbar. Then we have a design toolbar where we can do our 3D geometry. We have visuals such as the display, then assembly mode where we can do assemblies, constraints and things like that. And then we have a measure tool. Then there's also facets, which we won't talk about, but we have a repair where we can use to fix any geometry and find errors in our geometry. And then lastly, we have our prepare, where we'll be using the volume extract tool to create our fluid volume. All right, so that's basically the layout. Then there is this workbench, which we'll talk about sharing and then transferring it to Fluent. So the first thing I'm going to do, I'm just going to select this all and I'm going to change it to transparent. So I'm going to go to display, change it to transparency, and then it just gives me a little bit idea. I can see what's going on a little bit better. Okay, so with that, I'm going to start cleaning it up. So the first things are obviously these pipes. The only pipes I'm interested in are these two, so I'm assume this is out of the flow. So these pipes on the side I can remove. So I'll show you a couple ways of doing it. So the first one, I can right click on it and I can say locate in structure tree, and then I'll be able to see where the pipe is. So I can then select it and I can just select delete. Then obviously it's leaving a hole here where I would like to repair that. I just all I do is I go to design, select, I select that face and I press hit delete, or I can use the fill tool. Okay, and then it removes my face. Okay, so let me do another one. This time I'm going to triple click it and I'm going to select delete. That's also another way to remove it. Triple click it. I'm going to just show you where it is in the structure tree. And if I press delete, you can see it disappear. So we have part 3. Both of these are empty. So to clean it up, you can just say delete, right click, delete empty component, and you can see part 3 has disappeared. Then we'll just fix that hole. You can also use delete key instead of the fill, and it will remove it as well. Okay, so next one is this pipe over here. I can also use a box select, and I can hit delete, and it will delete the hole as well. So that's another way of removing them. Okay, so let me have a look. I think those are all the pipes that I don't need, and we can move over to cleaning up all the rest of the geometry. So there's a lot of things in here that are unnecessary. So for example, these, I can just delete them. I can say locate in tree. I can see it's these hoist brackets, so I can multi-select using shift, and I can select delete, and I remove those. Other things that I can remove are these support legs. I'm going to locate it in the tree. I see, okay, it's the support legs. I can then delete those. I do not need them in my CFD model. Other things are these rings around the side. Again, I can locate it in the structure tree, find out what it is, and then I can use delete to easily remove them. Okay, and the last thing, I want to get rid of this motor. It's not necessary, so I'm going to delete the motor and the gearbox. I'm only interested in the impeller itself. And the last thing is these internals. I'm just going to show you. So these brackets here, they could be, but they could, you may want to require them, but for this, I'm going to keep it simple, so I'm going to remove those as well. So let me just go back to that model, and I can hold shift and I can use my middle mouse wheel to change my selection, and then I can select, there's my support coils, so I can select them and I can delete them as well. Okay, so I've pretty much deleted everything that I'd require. So now let's just save it, and okay, so next thing is I need to look at stitching. I'm going to go to my repair tab. I'm going to select stitch, and I'm going to see, okay, this is actually, if I select it, it's escaped, select it, locating tree, I can actually see these are surfaces, so it didn't import correctly. So I'm going to stitch it, first stitch it, then let's check for any gaps, no gaps, missing faces, there is a missing face, and when I select that, now we can see it's converted to a solid, so we can move over on from there. So I'm going to just do my display again, and I can see all my components. Okay, so the next thing I want to do is I want to fix my impeller. So the first thing is I'm just going to go right click on my impeller and I'm just going to say hide others. Then it leaves me with my impeller and I have a lot of detail in here. I can simplify it. So I'm going to, so there's a few things I can do to simplify it. So the first thing I'm just going to do is I'm going to go to the design and I'm going to use the select tool and I'm going to delete unnecessary features. So the first thing is this. I can remove this. It's not really important. I can move that. Remove these certain faces. I'm just pressing delete every time I select it. And then let's delete these holes. Okay, I can use my selection and delete 3 holes at once. And then lastly, I can delete that. Okay, then I can delete that and then I can move that up to. So I'm going to choose my direction, going to move up to, and I'm going to choose that face. Okay, so that's sufficient. Okay, so there's other things now. Let's see, there's nuts and bolts here that definitely not going to be required, so I can triple click and delete it. Let's see if there are any others around. I do not see any. Okay, so the next thing I can do is I can look at fixing these holes. They're not necessary, so I can select it. I'm going to look in more than one body, so I'm going to search in all of the bodies and I'm going to select hole with equal radius. You can see it's multiple selected and it's selected a lot of them. And then I can just hover and I can press delete and it will remove that geometry for me or those details for me. Okay, so let me fix the impeller itself. Okay, so I'm going to just use the pull tool and I'm going to select that face and I'm going to select up to and I'm going to select that edge. I see there's a little bit of detail missing here, problem with that detail. So I'm actually going to triple click that, delete it, and I'm going to then mirror this rather. Mirror it. I don't want to merge the objects. So mirror. Sorry, escape. Let me do mirror. Do not merge. Keep that face. Okay. So I have mirrored it. I can see it's not perfectly aligned. So I'm just going to go assembly and I'm going to align that face with that. Okay, just hold on, sorry. Just want to triple click this. Now I'll go to the line. Okay, so there we go. I fixed that impeller. There was a little bit of an issue with it. I want to check if there's any other issue on any others. It doesn't seem like it. So now I can just continue fixing up the little holes that are there. So I'm going to just use my pull tool, which is like an extrude tool or manipulate tool, and I'm going to select move up to that face. Okay, can do the same for this other side. Okay, and then the last thing I'm going to do is I'm going to say combine, and I'm going to combine that. I'm also going to combine it with the shaft and combine it with that last part. Okay, I'll carry on fixing a few more things, and then I will get to where I need to be. So the first thing I'm going to do here is I'm just going to delete those chamfers. Yeah, get rid of all the small details, and then I can also merge those. So I'll go combine. Yeah, you can see there's a little bit of a hole in there. So
Hello. I do.
okay, and I can use box select, and I can just select delete. Right, then I need to fix this again. I can use the pull tool. I'm going to control, use that face. I can press U for up to instead. Press that, and then do the other side. Press U, and then I can combine them. Okay, and then let's look at the little bit of the detail at the top here. So I can remove this. And I'm just going to change the diameter of that so that it's slightly closer to what the other one. And then lastly, I'm just going to combine that with that. Okay, so the impeller is good. I can then, if I want to, I can change the color of it. Let me delete any empty components. I'm going to just show all again. Okay, so I've done the impeller, so I'm happy with the impeller, and I've removed all the different sections. Now I need to look for holes and anything. So I'm going to check just a cross section, and I'm going to look in here and see what my geometry looks like. Okay, so there's a couple things I can notice. There's a small gap there. These aren't really lined nicely, so it's going to create a little bit of issues. We can align those. And let's look up here. There's also issues here. And lastly, there's probably going to be a leak here. So we can simplify that area. All right, so the first thing I'm going to do is I'm just going to use my pull tool, and I'm going to manipulate these in my section mode, and I'm going to do that, then I'll delete that. Then I can use my combine. I'm going to say that shell, combine it with that as a cutter. I can remove those geometries that I no longer need. And then lastly, I'm going to say split body. I want to split the pipe, and I'll use the outer surface, or let's say the inner surface, and I can remove that. So that's nicely aligned now. And let's combine them. So I'm going to combine this, with that. Okay, another thing I can pick up there is just the radius of this. So I'm going to select that, and I'm going to go up to and select that just to remove that little lump. Okay, then I can do it the same on this part. I'm going to use my pull tool first, select that, just drag it. Then I'm going to select that and delete it. Go to my combine, select the shell, delete the components I don't need, and then use the split body to split that last piece there. Okay, and I can repeat it over here. Sorry, there's just a little mistake. Come on. Remove those. Let's go split body. Okay, so those are good. That's all good on this side. Let's rotate the view. Let's rotate it by 90 degrees. And I can see these other pipes here, so I can fix them in a similar manner. So I'm just going to use my pull tool first, delete that, combine. Okay, and lastly on this side, okay, so that looks all good, and I just want to check in that other manhole over there. Let's see there, that's also not great, so let's fix this area. Okay, and then I can combine all of these things. Okay, there's another one. I could just move that up. And I can combine everything. Okay, there's something wrong with this component. I'm not too sure why. Now let me just repair. try a few other things. I don't know why this is doing this.
I'm sorry, I think it's because you're working on a surface. I don't think it's all 3D. If I recall well, you said that's a surface.
Yeah, it is. I'm trying to repair it so that it will go into a 3D solid. There we go. I managed to fix it now. And let's go back.
Well done.
Very good. So now I want to finish up just combining all of these things so that we have one component. And let's combine this with that, with that, with the top, all of these other guys. All right, so most of that is all as one component now. Let me just add that last one. All right, so I've managed to clean up a lot more, so I'm just going to select these, triple click these. Move those. And then I think, oh yeah, there was just that gap there, so I'm going to select these faces. I'm going to select the move tool, select that face. I can go to selection, same size. Then I can drag them out a little bit, and then I can split them based on that bottom face. Okay, so now it's making contact and it's a little bit better. Okay, so let me go into this. I'm going to delete all my empty components. And let me check internally again to check if everything's all right. Okay, so I just want to double check, make sure all is good. Okay, so there's one more section I haven't fixed. So I'm going to delete this. Okay, so I think I'm all nearly there. I'm just going to combine these last few things. So that worked this time. And I'm just going to combine that last one. Impeller. Okay, so I think everything's good. We have all our geometry cleaned up. So the next thing we need to do is we need to create a volume extract. So the next thing I'm going to do is I'm going to just take all of these components. I'm just going to say delete empty, and I'm going to take all of these components and I'm going to move it into a new component. Again, let's just call this original. Right, and then I'm going to go to prepare. Well, the next, I just want to double check. I just need to check if there are any small surfaces. And there is one over here. So let's click fix them. It looks good now. Okay, so now I'm going to go to prepare and I'm going to go to volume extract. I need to select the inlets. I need to select my outlet. And then I need to select a seed face. Okay, and then I click complete. And then hopefully a fluid volume will be created based on the geometry I have. So there we go, a fluid volume was created, another one, a volume here. So I'm just going to rename that. And I'm going to call that fluid. And then out of my original one, I'm going to move this coil out of that. And I'm going to suppress this for physics because I don't need this. And then I'm going to say hide all suppressed. And then this is the only geometry that I actually need. Okay, so the next thing I need to do is create my because this is a rotating. Inside, I need to create what they call a rotating region in which the motion will be applied. Okay, so the first thing I'm just going to do is I'm going to add some planes. I'm going to add a plane using control. I'm going to select that face there. And I'm going to add another plane at the top of that impeller. There we go. Okay, and then I'm just going to move them up by 300 mils. So there's a bit of space between the rotating region edge and the impeller. Oh, so there was meant to be minus 300. Okay, I can hide this coil. I'm going to, okay, there's another thing here. I can see that. Let's just change that. Okay, get rid of that small edge. Okay, so now I'm going to use split body. I'm going to split that once, this one as well. And then I'm going to hide these other ones. And then I'm going to create a sketch. So that's about, so I want it about halfway Let me see where the coil is. Okay, so let's say about 2,400. Okay, I'm going to complete that sketch. I'm going to select my pull tool. I'm going to select that edge. I'm just going to extrude it, create a surface, and then I'm going to split body with that as well. Okay, call this rotating, and then we can merge all the others. And let's just call that fluid volume. Okay, I can delete that surface. Then I just want to combine this and that. I want to remove that internal part. Okay, so now if I hide the coil, you can see there is an outline in there. And then I can delete anything I don't need. And if I wanted to, I could delete this original, but it's not necessary. Okay, so the next thing I need to do is called name selections. And name selections are useful to applying certain conditions at different points in my geometry. Okay, so we're going to create name selections. The first thing I'm going to do is I'm just going to hide the coil. Well, actually, sorry, I'm going to, let's hide the coil. And I only want the fluid. So I go to groups, and then I use my select tool, select that face, create a name, let's call that inlet 1. My other face, inlet 2. Call that outlet. Then the thing is, I select them and I'm going to hide the faces so that makes it easier for me to select what I require later on. Right. I'm just going to hide my rotating region because I'm not too interested in that just yet. And I'm going to select, go from a view, just go to the front view. And I'm going to select this section here. And I'm going to create a group and call that wall. Okay, then I can select that as well and hide the faces. Then I am going to select this internal region here. I'm going to create a name for internal. Hide that. And then lastly, I'm going to, well, not quite lastly, but I'm going to use box select. Select those, that face, create a wall, coil. And I can hide that face. Okay. Okay, so that's seems to be all good. Let's just double check. I just want to check. I think that's all going to be fine. Just going to remove that. That's small details I don't need. Don't see it on that one. There's I'm just removing a few other small features that I see. Okay, so I think I'm good now. So I've created name selections. There's my shell, my coil, my internals. So I'm just going to hide the others, and I'm going to go back to my rotating region, and I'm just going to go to the front. And then I'm going to use box select. You select that impeller, box select. Oh, sorry, I made a mistake there. I mustn't have that. Just go selection, box select, hold control, box select. And there I'm going to create a name, wall. Okay, and then the last, select these faces. Okay, so if I check that, let's show all. I just want to check with my shell, my faces, hide. And it seems like everything's separated, so it's all good. So I can then move over to my Fluent Meshing part of it. Okay, so I'm going to just show all again, and I'm going to switch off this. And the last thing I need to do before going to Fluent Meshing is selecting Shared Topology, and that's just to make sure that your mesh is conformal when you create your mesh, and that each surface is coupled and that the mesh aligns on those surfaces, matching surfaces. So we allow that to happen, allow that for a little bit of time. Can take a little bit, depends on how big the model is and how many faces it needs to share. But it seems to be good. It's shared those. Let's box select and let's complete. And then these lines showing that there is sharing, and I think that we are all good now. Okay, I just want to add, just want to go to select. That's also my coil. I'm just going to right click add. So it's a bit more of the coil, not just that. All right, so I can save that. Then I can go to Workbench, Fluent, and I'm going to choose watertight geometry. There, if you have clean geometry, watertight geometry is the best tool to use. We can use double precision, how many meshing CPUs you have. That depends on the license you have available. And then I click OK. And then it opens Fluent Meshing, where I can then create any refinements and that in specific locations. Okay, so let's allow that to import. So it's going to import the geometry into meshing now. And this is our new window is Fluent Meshing, where we can then obviously assign various meshing conditions. So the first thing is just importing geometry. We have advanced options, but I'm going to leave it as that. I'm going to add some local sizing. The first local sizing I'm going to add is a body sizing to my coil, and I want that to be 20 mils. If you're not sure what your unit is, you can just look at this import and see there it's millimeters. So all these values here are in millimeters. Okay, then I'm going to add another sizing. I'm going to add a face sizing. I'm going to say 10 millimeters, and I want that on my impeller blades and shaft. Okay, and I'm going to say add. And then lastly, I'm going to add a proximity so that I have most of my channels refined. So I'm going to add 10 minimum, and I want at least 5 cells through my gaps. I'm going to have that on faces. Just faces, and I want to apply it to my rotating and my fluid region. I can add that proximity. Once my proximity is done, then I can move over to my surface mesh, and I can define my minimums and maximums. So I'm going to say 10 mils minimum, 50 mils maximum. I want 1 cell. This is my default curvature, so it's going to divide a circle up into 20 straight sides. So that's my basic default, so these edges, and I can select generate surface mesh. Okay, this is going to take a little bit of time. Yeah, so we can let this go and we can watch it. It will just take a little bit of time, and then I can move over. Is there any questions so far? We have covered most of what we wanted to do today. So if you have any questions, you're more than welcome to ask while we wait for this to finish meshing, and then I can discuss that. So yeah.
There is a few questions, Keith.
Okay, cool. Let me see.
Just have a look in the chat. There's one, after sharing, is a face highlighted in yellow? What does that mean?
Okay. So the face highlighted in yellow. So if you want to, you can see what it means. So here we have to show what visualizations we want to see, and we can see what faces are shared, etc., etc. But if you want to know what each means, that's the lines, what that each means. So if there's a blue line, that means there's 2 edges contacting. If there's then there's more than 2 lines, and if it's yellow, then it's even more than, that's more than 3. So that's all that the yellow line means. So it's not necessarily going to be a face that's highlighted yellow. It would be an edge rather than that is highlighted yellow.
So that's, and then there's another question. Is it possible to make sizing that are relative to another? Is that question clear?
Okay, so yeah, so you can't make, your sizing is going to be absolute. So you can, all your local sizings you can make smaller than your global mesh, not larger than, but you can't scale them relative. It's always going to be an absolute value based on millimeters. So you're going to have a minimum size and a maximum size, or a local size for that. So you can't define them relatively based on one another, but you can obviously indirectly do that by just specifying the actual size in millimeters.
Is there any other questions before we move on?
Okay, so it is still busy meshing. It does take a little bit of time, particularly because of the spiral. It's fairly complex so it will take a little bit of time. So I'll leave it here and we can then continue. So there are some more questions I see. Yeah, we can share the import files. I see I made a mistake and I actually overwrote my original files, but I will share the final ones without no problem. Okay, so yes, can CAD designs from other software be used? Yes, it can. So they've done a lot of improvements on Fluent that you can then import certain additional CAD into into Fluent. So there are options, but it's nice to work through SpaceClaim first to do your cleanup. You could possibly do your cleanup in your other CAD package, but then also things like creating volumes, fluid volumes and things like that. It's easiest done in SpaceClaim, but it can definitely be done in Fluent Meshing, but it's not the easiest way to do things. Okay, so what makes Fluent Meshing better than other meshing softwares? I think they've worked a lot on the meshing technology, and they have now what they have fully polyhedral cells, which are very robust cells. Then they also have what they call polyhex core, where your surface mesh is polys and your internal mesh is a hex core kind of mesh, a Cartesian type of mesh. So I think with that technology, Fluent Meshing has become very strong at what it can do. And then just the user interface, the water chart geometry, it's a fairly straightforward step-by-step process which it guides you through. And I've already done a surface mesh with very little inputs, and it's busy doing a surface mesh, and it's yeah, so the user interface has been improved significantly. So it's one of the easier tools to use, as well as having very good meshes that it can produce. And then what's the relationship between the amount of cells in the RAM? Okay, that does depend on the type of cell. So you could generate a tetrahedral cells. Those are the lightest, but generally you have more cells per volume than any other cell. So it uses the less. It's about 1 million cells uses about, or 2 million cells uses, 1 million cells uses about 2 gigs of RAM. Where if you move over to polys and polyhex core, you're looking at about, per million cells, you're looking at 6 gigs of RAM. But the thing is, you have the trade-off of obviously the tet and the hex with the RAM, but ultimately for the number of cells that are required, your tets always need more than your polyhex core mesh or your poly mesh. So they use similar amounts of RAM for a particular size, but you can work, so for tets it's about 1-2 gigs of RAM per million, where for your hex and poly it's about 6 gigs per million. Okay, so there's a number of ways that we can do mesh adaption. So the first would be just a manual import, where you could work through Workbench, where you can drive these different dimensions. Alternatively, you can just do them by yourself. So I would just copy this mesh. I would change my refinements on these body sizings and my surface mesh. And then from that, I can refine and refine. So that's one way of doing an actual mesh refinement study. The other method would be to use the mesh adaption tools. And the mesh adaption tool you can allow to solve, to refine based on gradients in your domain. So higher the gradients, the finer the mesh will be, and you can have control over where it refines, how it refines, and to what level it refines. So you can do explicitly a mesh convergence study where you control, just keep reducing these local sizings and your mesh sizing until you get a converged solution. Alternatively, as I said, you can straight off the bat use the mesh adaption, where it will adapt automatically while it is solving. And that's generally the better approach. It's a little bit more robust, and yeah, it's easier to use in the end. Okay, so let's have a look at my geometry so we can see what the mesh looks like in here. We can see what it looks like on the blades. It's fairly fine, and we can see what it looks like around the coil. Okay, so we are good with that. So the next thing we can do now is obviously we can just create geometry. So I'm going to say it's both fluids and solid regions and voids, and I don't need to share a topology. Okay, then I can specify my boundary conditions. These inlets are velocities, one pressure outlet. My internal is an internal and the rest are walls. I can select update, create regions. I have 2 of them. Allow that to update to create one more the 2 regions. The 2 regions, one being they're actually 2 fluid regions, one coil, which I assign solid, my rotating region, which is a fluid, and then my other fluid region, which is also a fluid. I can then update them. I can then add boundary layers. So I'm going to say, for example, I want 10 layers. I'm going to use smooth transition. If you have a good idea of what your boundary layer Y+ should be, and you know the size of the first cell, you can use the uniform and define the initial height of the first cell. The most easiest is just use smooth transition. I'm going to use that, specify number of 10, and I'm going to add boundary layer. And then lastly, I'm going to generate my volume mesh. So I have a couple options: tetrahedral hex core. Hex core, basically, it's a tetrahedral surface mesh and a hex core volume mesh. Polyhedral, full polyhedral mesh, and a polyhex core. I like the polyhex core the most. It has the benefits of polys as well as it has the benefits of Cartesian mesh. All right, so I'm going to then click create, and then this should take some time again where we'll allow it to mesh. So I think that's where we will end today. If you have any questions, I'll show you the final mesh next week, Friday, and then we can discuss that further. So any more questions, I'm happy to answer.
So any more questions for today? Thanks a lot, Keith. I think that's everything for the day then. Wait, here's another question.
Okay, cool.
There's a hand, let's just see. Yeah, any difference in sharing topology in SpaceClaim versus in Mesher?
Okay, so theoretically no, but when you're doing shared topology in Mesher, it's actually done after the surface mesh. So essentially you do the surface mesh twice when you do shared topology in Mesher. So I prefer to do it in SpaceClaim, but you're more than welcome to do it in Fluent Mesher. But as I said, you do the shared topology when you're describing your geometry. So it needs to remesh that, remesh the surfaces that are in contact where there will be shared topology. So again, it doesn't really matter too much, but it's easier through SpaceClaim. But if you are struggling, then you're more than welcome to do it in Mesher. And for example, if you were to import geometry directly out of some other CAD package, then obviously you would want to do your shared topology in the Mesher itself. Okay, so there it says many beginners don't understand the importance of Y+ in the boundary layer and how it impacts flow, especially in heat transfer. It'd be good to have a quick webinar insert on it in this course. Okay, so let me just discuss that in general. So Y plus gives us an idea of where the boundary layer, where the first cell sits in the boundary layer. So by default, we assume the law of the wall, and that is a logarithmic function. Well, the first part's a linear, then a logarithmic function for the velocity close to the wall. So a y plus of above 30, below 300 is good for empirical relationship for the law of the wall. So we're using an empirical relationship to solve for the boundary layer. If you have a y plus of less than 5 or less than 1, particularly if you're doing with high important pressure drop and heat transfer, then your y plus should be less than 1. And that just allows that your first cell layer falls in the viscous layer of your boundary layer, and it then will refine, will capture your boundary layer using the cells and won't use an empirical relationship. So it depends on your situation. If there is things like store or things like that, then your boundary layer should, your y plus should be less than 5. But if you have general flow over an aerofoil, for example, or general flow over a car, and you're not too interested in drag and things, you'd want to look at the general flow, then a y plus of between 30 and 300 is good. Okay, so I hope that's explained y plus. If we want to, I can delve into it more detail later on. I can show us in equations where what are required, but ideally you want a y plus of less than 5 or less than 1 for good pressure drop and heat transfer calculations. Okay, peel layers have more or less. Okay, so default peel layers is fine using 1. If you really want to, you can go to 2, but it's just basically the number of layers between your surface mesh and in your inner mesh. And yeah, so the peel layers, if you, 1 is perfectly fine. If you want to, you can. Higher is better and more robust, but again, it's just going to create more cells than required. So the default of 1 is sufficient. If you really require, you can go more. So what is the scripting language for Fluent? So the journal files, I can't remember what, there's a number of tools. So Fluent itself is Scheme, but I think journal files and things like the journal files themselves use just the TUI scripting, and then any other like UDFs uses a C file, which you can then use to do any scripting. So the one nice thing is, so Fluent and Fluent Mesher have the scripting, and now Fluent has what they call expressions, where you can then get away with a lot of your calculations and your manipulation through the expressions rather than using scripting. So yeah, I will then get a bit more information on Y+. I have a short presentation where I can show that to you, because it is very of much importance when you're doing heat transfer curve, conjugate heat transfer. So yeah, I see the mesh is still busy. It's almost complete. So if there anyone says maximum aspect ratio in the surface prism cells in Fluent, laminar sublayer in turbulent flows can be quite small. Yeah, so generally, why Fluent doesn't like aspect ratios too much more than 100. 100 is probably your best bet to go for, nothing more than that. But to be honest, if your first layer is less than 1,000, it is sufficient. As long as there's no transverse flow over that high aspect ratio cell, then it should be fine, as long as there's no transverse flow. The errors come in with aspect ratio when you have transverse throw, so it's going through at an angle and it's not perpendicular to the faces. So yeah, ideally, try go for 100. that's your best. If you have to go more, it's fine. But as long as it's a more than less than 100 in anything other than your first line, your first cell. The second and more should be less than 100. Your first can be less than 1,000. So that can get quite small depending on the flow conditions, because it depends on velocity and your viscosity and your density. So we can talk about that, but it can be very small when you're dealing with y plus of 1. Okay, so the mesh has completed, so we can have a look at what our mesh looks like. So you can see what our boundary layer looks like. Then you can see our peel layer, and then you can see our hex core dominant inside. And you can see the boundary layers around there. You can see what the inside of the solid looks like. And this looks like a fairly good mesh. We have our boundary layer over our blades there. So this is good, and we could probably then save this. I'm going to write this mesh, and then I can move that to my CFD prep, CFD setup. Right, so I don't know, there's no more questions coming in, so hopefully I've answered what you have. As I said, next week I will discuss Y plus a little bit more. If there is anything CFD related that you would like me to discuss, drop just a question, and we can discuss it. So if there's anything bothering you, or you want to explain a bit more detail, you're more than welcome to ask, and I'll do my best to answer your questions.
Okay, thanks a lot, Keith.
Sure.
And thanks everybody for attending. We will continue next week, Friday at 12 p.m. again.